Now we are going to study question from July 2019 exam, question 2. So give the heading July 2019 exam, July 2019 exam, question 2. Now I am going to read this question for you guys. Try to see the scenario here. We have a what we have? Steel wedge whose length is how much? 450 mm long. Try to see the scenario. We have what, guys? Steel wedge whose length is 450 mm long, 55 mm thick at the butt end, okay, and 5 mm thick at the sharp end. See, butt end and sharp end. See, they have given the drawing in the question. Huh? Try to see the drawing here carefully. It is driven horizontally. See the point, next point. It is driven horizontally between an engine bed plate and the stool with a force of 4.5 kilonewton. What they are saying, guys, I am reading once again. It is driven horizontally, means we are going to drive the wedge into the engine bed plate with a force of what, guys? 4.5 kilonewton. So here, see, in earlier questions that we have discussed, earlier question of wedges, in that questions what we discussed, they have given us, means in that questions, our target was what? What was our target? Our target was we have to find out force required to drive in the wedge. That was our target in that questions. But here in this question, they have given us a force in to require the, means they have given us a force. How much force they have given us? 4.5 kilonewton to drive the wedge into the bed plate. So here they have given us a force in. The coefficient of friction is what? 0.15. Coefficient of friction is what? Mu. Try to see the scenario here. Now this question is also very easy question, not that much difficult question, because now we have till now we have solved 2 questions of wedges. This is the 3rd question. After that there will be one more question. It is from recent exam, that will also we are going to see. Now try to see the scenario here in this question, what we have to see. Now what they have given us, engine bed plate. Try to see the scenario, what they have given us in the question. They have given us, suppose this is the engine bed plate. This is what a engine bed plate. Then this is a wedge. This will be what? Sharp end of the wedge. This is what, guys? This is a sharp end and this is a butt end. Try to see the scenario. Sharp end and butt end. Try to see the drawing here carefully, everyone. Always try to draw the bigger drawings. In mechanics, the only important thing, not only, most important thing, most, n number of times most, the drawing is most important. So this is what a stool. See the point here. Now here, how much these dimensions they have given us? How much this dimension they have given us, guys? This dimension is how much they have given us? This much. This is given us to is how much? 5 mm. This is a sharp end. Then what about this one? How much? This much they have given us. This is what? A butt end. How much is the butt end? 55 mm. And guys, this drawing is not to the scale. Otherwise you will say, sir, this 5 mm is bigger and this 55 mm is not to this. So initially I am saying this drawing is not to the scale. So this will be what, guys? 55 mm. Check it, guys, everyone. Now here they have given us this much length. What will be this much length? In the drawing they have given the length of the wedge. How much length of the wedge they have given us? In the drawing they have given us what? What they have given us? They have given us a length of the wedge. How much length of the wedge they have given us? This length is how much, guys? 450 mm. See the point, see the drawing here carefully. So this is 450 mm. Now guys, try to see the scenario here. Here they have given us one important point. I am going to read the question once again. A steel wedge 450 mm long. So here we have a steel wedge whose how much is long? 450 mm long, 55 mm thick at the butt end and 5 mm thick at the sharp end with an equal taper on both sides. Guys, see the word, what they are saying? Equal taper on both sides. What is the meaning of equal taper on both sides? See, Here I am drawing one dotted line. See. Here also I am drawing one dotted line. See the point here, guys. Everyone, side try to see this. Equal taper on both sides means what? This angle. This angle is alpha. And then this angle is also what, guys? Alpha. That is meant by equal taper on both sides. So you got it. So here also alpha, guys. And here also alpha. Try to see the point here, everyone. So here also alpha and here also alpha. Now the next scenario is what, guys? Now how much force they have given us? F in. In the question they have given us a force in. F in they have given us. How much F in they have given us? 4 kilonewton means what? 4.5 into 10 raised to the power 3 Newton. So 4000, or in other words, we can directly write down it is 4500 Newton. Guys, are you getting my point? Try to see the scenario. So in the question they have given us the force required to drive the wedge in this engine bed plate. So this is what our guys. So this is what engine bed plate. See the scenario here. Engine bed plate. This is what a stool. See the point here, everyone. Try to see the scenario here. Now in A part, any doubt in this discussion, guys? Any doubt in this discussion? Now in the question they have given us what they have given? In the question they have given us what? Coefficient of friction. How much coefficient of friction they have given us? Mu is equal to how much? 0.15. What they have given? Mu is equal to 0.15. So in the question they have given us a mu. Mu is what? 0.15. That is what a coefficient of friction. If mu is what? 0.15, then what will be the scenario? Phi will be equal to what, guys? Tan. Phi means what? What is the meaning of phi? Phi means angle of friction. And then what is the angle of friction? Angle of friction means what? Tan inverse of mu. What is the meaning of angle of friction? Angle of friction means what? Tan inverse of mu. So phi will be equal to tan inverse of mu means what? Tan inverse of 0.15. Tan inverse of what, guys? Tan inverse of, see the scenario here, everyone. 0.15 tan inverse of 0.15. So please everyone do the calculation and tell me the value of tan inverse of 0.15. Everyone, please everyone do the calculation, tan inverse of 0.15 with me. So what will be the value of phi we are getting? 8.5308 degree. So we got the value of phi. What we got, guys? We got the value of phi. Then guys, to solve the questions further, we need this angle alpha. To solve this question further, what we need, guys? We need this angle alpha. This angle of this wedge. Okay, this taper angle. So alpha. How to calculate this alpha? So for calculating this alpha, try to see the scenario. Now guys, try to observe this drawing carefully. I am asking you one important question for all of you. Okay. Try to see the scenario here, everyone. What will be this distance, guys? What will be this distance? This distance will be what, guys? This distance will be what, guys? See, both the distance will... yes. 55 minus 5. See. Correct. Very good. So, 55. We will subtract minus 5 from that. So this summation of these two distance will be what? 50. This one. So this is this one plus this one. These two distance will be what, guys? 50. So this will become so. So this will become what? 25 mm. And this will also become what, guys? 25 mm. Okay, any doubt in this 25 mm? Guys, in this question, means while during this exam, when I have taken feedback from my student during this exam, they got confused, means how to take out this angle. Means they have wasted a lot of time only on this angle only. Means they got confused. How to find out this angle? They have not given angle. So here, how to get this angle? For getting this angle, we have to find out this 25. And you got this 25. See, this complete is how much, guys? 55. If you subtract this 5 from that one, what will remain? Means this one, this green one and this green one will be what? Their summation, this one. And this summation must be what? 55 minus 5. So this much 55 minus 5. See the point here, huh? I am not drawn proper straight line. Okay, let me draw proper straight line. Guys, always remember, huh? I am saying time to time. I am telling you like. So now try to see the scenario here. So this green one will be what, guys? 50. Their summation. So then this will become 50 by 2 and this will become 50 by 2. 50 by 2. 50 by 2 means what, guys? So or in other words, 25 plus 5 plus 25. So this 3 summation must be equal to what? 55. And we are getting, so read out in this 55. So why we calculated this 25 mm? Because we have to find out this alpha. And how to get that alpha? See, this 55 is what, guys? Sorry, this 25 will be what? This 25 will be what? Opposite to alpha. 450 is what? Adjacent. What is the relation between opposite and adjacent, guys? What is the relation between tan? Okay, very good. The relation is what? Tan. Okay, good, very good. So tan alpha will be equal to what? Tan alpha will be equal to what? 25. Or in other words, in in meter, 0.25 divided by what, guys? 450 mm adjacent. So it is wrong, 0.025 and then 0.45. So alpha will be equal to what, guys? Tan inverse of 0.025 divided by what? 0.45. Everyone please do the calculation and tell me the value of alpha. Everyone please. Three point 3.179. What, guys? 3.1798. So can I take 3.18 degree? Can I take like this? 3.18 degree. Is it okay, guys? 3.18 degree. Okay, is it okay? So we got phi and alpha for this question. What we got, guys? We got phi and alpha. Now we are going to see what they are asking us in the question. In the A part, what they are asking us in the question? The equivalent mass lifted by the wedge. Means how much mass is going to lifted by the wedge. So here there will be load will act. So this is what? This load will be what, guys? mg. So in A part, what is our target? What is our target in A part? In A part we have to find out, guys, what we have to find out? Mass m. See, earlier questions, in previous 2 questions of wedges, they have given us this load mg. They have given us mg directly in Newton, or they may give mass. In one question they have given us mass. Okay, from mass we have calculated a total load. But here what they are asking us? They are asking us mass m. They are asking us, guys. Try to see the scenario. How much mass is going to lifted by the wedge? Means what will be the capacity of weight, this wedge, for this given scenario when the force of 4500 Newton, how much load is going to lifted, how much mass is going to lifted. So here our target is what? Here scenario is what? Inverse of the previous 2 questions. Means earlier questions, this thing is given and we have to calculate force in. What we have to find out in? What we calculated in previous questions, we calculated F in. But in this question, they have given us F in, and what we have to find out? We have to find out M. Okay, guys, are you getting my point? See the scenario here. Here, scenario is the inverse scenario. Okay. So, please everyone. So, first of all, what you have to do? Draw this drawing properly, everyone. After completion of drawing, write down these all things properly. Okay, guys, please. Now, guys, what is our target here? Now, guys, what is our target? What we have to find out? We have to find out mass m. Okay. What we have to find out? We have to find out mass m. So, how much alpha we calculated? For my reference, I am writing alpha here. How much alpha we have calculated? 3.18 degree. Don't write this one, guys. I am writing for my reference. And phi is how much calculated? 8.5308. Guys, see the scenario here. Now, guys, if you remember our earlier theory, when phi is greater than alpha, what will happen? When phi is greater than alpha, object will not come down automatically to the plane. We have to apply some force. We have seen such type of things. That thing we required in next part, guys, B part. Try to see the scenario here. So these are the two given things, and what is our target? We have to find out mass m. Mass m is our target. Now, for this scenario, for what we are going to do? We are going to draw force diagrams for this one, guys. So first of all, see, I am going to separate this one. This is engine bed plate. This is what, guys? Wedge. Engine bed plate, tapered wedge. Okay. So first of all, this is what, guys? See the scenario here, guys. This is what engine blade plate. Now there are forces. There will be some force will act. If you want to move the engine blade up, guys, there must be some force must be from this side. There must be some force from this side. Then and only then engine bed plate will go up. Guys, try to see the scenario here. If force on this side, then and only if there will be force on this side, then and only engine bed plate will go. Means the remaining part of the bed plate will apply opposite force. Means which try to go this side, the remaining part of the will apply force like this. Try to see the scenario here, guys. So now I am going to draw the drawing for us, guys. See the drawings here carefully. Please always mechanics, of proper drawings. So this is what our engine bed plate. Then here I am going to draw. This will be what our. This will be what, guys? Here I am going to draw the wedge. This will be what? A wedge. See the scenario here. This angle and this angle must be look approximately same. Okay. Then here what? Here we have a what, guys? This is what a mg. Here we have a what? R. Here what we have? Guys, what we have? We have a force in. How much value of force in? 4,500 Newton. 4,500 Newton. Okay, guys, are you getting my point? Try to see the scenario here, everyone. Everyone, try to see the scenario. Now, guys, what will happen? What is happening? As this wedge, how is the motion of the wedge? Wedge motion is this side. Motion of the wedge is what? This side. Wedge try to move this side. Motion of the wedge this side. Now here there will be what, guys? Normal reaction. Normal reaction is what, guys? Always normal to the plane. And this normal reaction we will say it as what we will say? We will say Rn1. Okay, try to see there. Or we will say, we will keep it as a Rn2. Same like a practice like yesterday. So this is what Rn2. Then motion is like this. Then friction force will be what, guys? Friction force will be what? Opposite to the motion. Friction force will be what, guys? Opposite to the motion. See the scenario here. So this is what our Rn2. Rn2, what is Rn2, guys? It is perpendicular to the plane. This plane. Then there will be what, guys? Friction force. This will be what, guys? Friction force. And this friction force will be what? What we will name? We will give the name Fr2. Try to see the scenario. So this is what one story. Then here what we will have, guys? Here we will have again normal force. Normal to the plane. And we will say it as a Rn1. Try to see the scenario here. Rn1. Then this will be what, guys? This will be what? Friction force. And what we will say that friction force means what? Fr1. So action opposite side will be what, guys? Action opposite side will be what? Reaction. Okay, so I try to see the scenario. So if Rn1 is this one, so same will be on this one also, Rn1. Friction force on this side. So here how will be the friction force? It will be like this. Okay, see the scenario here. So this one will be what, guys? Fr1. Any doubt in this drawing, guys? See the scenario here. Now next point is what? Here how many forces initially? Here how many forces initially on this drawing? 4 forces. So we are going to replace these 2 forces by their resultant force, and this resultant force will be what, guys? Resultant reaction. So this resultant force is what? A resultant reaction. Try to see the scenario here. And this resultant reaction, what we will say? This resultant reaction means what? What we will say? R1. And what is the angle of R1? What is the angle of resultant reaction and normal reaction? That angle is what? Phi. And coefficient of friction is what? Same for all plane. So angle of friction is also same here. Means here, here, here. So same phi. Then here I am going to draw one vertical line. So this angle will be what, guys? What will be this angle? See this angle only. Alpha. This is what, a vertical line. Try to see the scenario here, everyone. This is what, a Rn1. Any doubt in this drawing, guys? Any doubt in this drawing? This drawing is okay for everyone? Now? Okay, good. Now try to see the scenario here next. On this drawing. So, here also we are going to form one rectangle like this. See. So this will be what? This will also what will become? Same R1. Same R1. Angle of R1 with respect to angle of resultant reaction with respect to normal reaction. What will be that angle? This angle will be what, guys? Phi. Try to see the scenario here, everyone. So this will be what, guys? Rn1. Try to see the point here. Then next point will be what? Next point, this is what, a vertical line. This is a vertical. This is a what, guys? Vertical. So this angle will be what? This angle will be what, guys? Alpha. Okay, see the scenario. This angle is what? Alpha. See, what same angle. Here I am showing alpha. Here also I am showing alpha. Alpha. See the drawing, guys, everyone. Any doubt in this drawing? Now the next point is what here? Here we are going to replace these 2 forces by what? Their resultant reaction. What is their resultant reaction? For that purpose, for getting resultant reaction, what we are going to do? We are going to form a rectangle, and this will be what, guys? R. What we will say? This R we will say as R2. What we will say? This R as R2, and this angle will be what? Phi. And why we are taking everywhere? Here also phi, here also phi, here also phi. Because coefficient of friction is same for every plane. This plane, this plane. So coefficient of friction is same. So that's why here we are taking phi. If coefficient of friction is different, then we will take a different angle of friction. Then here will be same, but here will be different. Okay, guys, are you getting my point? Same. See the scenario here. Now the next point will be what, guys? This will be what? Vertical line. See, this is a vertical. Everyone, try to observe the things carefully. So this angle will be what, guys? This angle will be what? Alpha. This angle will be what, guys? Alpha. Okay. Any doubt in this discussion, guys? Drawing is okay for everyone. So please, everyone, any doubt in this drawing? Please, guys, observe this drawing. Please observe this drawing. If you have any doubt, please ask me quickly. Okay, good. So no doubt, no problem. Please, everyone. Anyone have any doubt? Okay, good. Very good. So, please everyone, try to draw this drawing properly. Now try to see the scenario here, guys. What is our target? What we have to find out here? Now in this question, what is our target? What we have to find out? Our target is what? In A part, what we have to find out? We have to find out this mass m. And how to find out mass m? Try to see the scenario here. Guys, how to find out mass m? How to deal with, for how to get mass m in this scenario? So here in earlier question, we are always going to start with our engine bed plate. But in this scenario, what we are going to start with what, guys? Wedge. Okay. Here, guys, add in this drawing. Add, this is what our wedge. Everyone add this one wedge. And this is meant by what, guys? Engine bed plate. So here try to see the scenario here everyone. So we will first of all consider for wedge. What we are going to do? We are going to form a force vector diagram for wedge. Means with the help of wedge we are going to find out R1, and with the help of R1 we are going to find out M. Very simple scenario. And guys, so try to see the scenario here. So first of all we will start with what guys? F in. This will be what? Our force in. Okay, this is what our, see the point. This will be what? Our force in, horizontal force. If force in, then this will be what guys? This force will be what guys? This force, see this side, what will be that one? This will be what guys? R2, very good. And then this force will be what? This force will be what guys? R1. R1, very good. R2, R1, any doubt in this discussion? Now, I am going to draw vertical lines here. I am going to draw what? Vertical line. So this is what? Our vertical line. This angle will be what guys? What about this angle? See the drawing here. What is the angle of R2 with respect to vertical? See. This is what? Our R2. See the scenario. This is what? Our R2. Angle of R2 with respect to vertical. This is what? Our vertical. So this is what? A vertical. So this angle of R2 with respect to vertical is what guys? Alpha plus phi. This angle is what guys? Alpha plus phi. Or if this angle is here, the same angle will be here also. Alpha plus phi. This is for our reference, huh guys? So you got it. So same alpha plus phi we can denote here. So here what we can denote? This angle will be what? Alpha plus phi. And this is what? Our R2. Okay, good. Then what about R1? What about R1 guys? This angle will also what guys? Alpha plus phi. Same. Angle of R1 with respect to vertical. So alpha plus phi. Okay, any doubt in this discussion? Now then what we are going to do? We are going to assume. What we are going to assume? We are going to assume this angle as what guys? Theta 1. This angle as what? Theta 2. Is it visible to everyone properly? Then this angle is what? Theta 3. Any doubt in this discussion guys? Any doubt in this discussion? So we got it. Now what we need? If you want to solve this question, we need theta 1, theta 2, theta 3. Theta 1 will be what guys? Theta 1 will be what? What will be the theta 1 everyone? Theta 1 will be what? 90 minus what guys? 90 minus alpha plus phi. See the scenario here. 90 minus alpha plus phi. So what will be the scenario here? 90. So 90 minus alpha is how much guys? 3.18. Phi is how much? 8.5308. See the point here. So what will be the value of theta 1 we will get? Please everyone do the calculation and tell me the value of theta 1. (90 minus 3.18) 78 point how much guys? 78.2892. How much? 2892 degree. Okay, good. So we got it what guys? We got theta 1. And see, here also alpha plus phi, here also alpha plus phi. So theta 2 will be also equal to what guys? Theta 1, 78.2892 degree. Are you getting my point? So we got it theta 1, theta 2. See, theta 1, theta 2 will be the same. And then what about guys? Next point. What about next point? See the scenario. Theta 3 will be what? Theta 1 plus theta 2 plus theta 3. Sum of three angles of triangle. Sum of three angles of triangles will be what guys? 180 degree. So theta 3 will be what? 180. Theta 1, theta 2 is the same. So can I take directly 2 minus theta 1? Theta 1, theta 2 is the same. So theta 1 plus theta 2. 2 times theta 1. Everyone is getting my point? So theta 3 will be equal to what? 180 minus 2 times theta 1 will be how much? 78.2898. 78.2898. So please everyone do the calculation and tell me the value of theta 3. So 180 2892. Okay, that is what 2892. Okay, by mistake. 23 point how much, guys? 23.4216 degree. So we got it theta 3. Why we calculated theta 3? Because see, F in opposite is what in this force vector diagram. This is what our F in. Okay, F in opposite is what? Theta 3. R1 opposite is what? Theta 1. So what we are going to apply? By what, guys? By sine rule. What we need guys? We need what? R1. What we need, guys? We need R1. R1 opposite is what? Theta 1. So R1 by theta 1. Everyone please observe this one. And what is opposite of F in? F in by what, guys? F in by what? What is opposite to F in, guys? F in opposite to what, guys? Theta 3. Okay, is it? I am writing theta 1. It is should be sine theta 1, huh, guys? Please always tell me if I am doing mistake. So R1 by sine of theta 1. F in by what, guys? Sine of what? Theta 3. So what will be the, guys, R1? What will be the R1? R1 will be what, guys? F in, check it out, everyone. Sine of theta 1 divided by what, guys? Sine of theta 3. So how much F in with us? F in is how much? 4500 Newton. F in is how much? Force required to drive the wedge in. It is what? 4500 Newton. It is given in the question. Sine of theta 1. Theta 1 we calculated 78.2898 divided by what, guys? Sine of, so R1 4500 multiplied by sine of what, guys? 78.2898 divided by sine of theta 3 we just now calculated 23 point how much, guys? 4216. So please everyone tell me the value of R1. Everyone please tell me the value of R1. Please try to do the calculation properly, huh? And always try to do the calculation with me. One one zero 11085.304 unit is Newton. Okay, guys, so we got it R1. So we got it R1. By using R1 we are going to find out mass here. Please everyone write down up to this point. Everyone please write down up to R1. So what is our target here, guys? What is our target? We have to find out mass m. For mass m we calculated R1. I am writing here for my reference. How much R1 we calculated? 11085.304 Newton. Now so here we calculated R1 by using wedge. Now we will come to the engine bed plate. Let's try to see the scenario here. Story is very simple, not that much difficult story. See the point, guys, everyone. So what will be the scenario here? So now we will come to forward, guys, for engine bed plate. See the point here. For engine bed plate. So what will be the scenario for engine bed plate? This will be what, guys? Okay, this will be what? mg. Then there will be what, guys? Resultant reaction what? R. And then there will be what, guys? Here this will be what? R1. And this angle of this one is what, guys? Alpha plus phi. Angle of R1 with respect alpha plus phi. Angle of R1 with respect to vertical alpha plus phi. And we calculated R1. So try to see the scenario alpha plus phi. This mg is what? Adjacent. R1 is what? Hypotenuse. What is the relation between adjacent and hypotenuse, guys? What is the relation between cos? Okay, good. So what we can write? Cos of, see the scenario here. What we can write? Cos of what? Alpha plus phi will be equal to what, guys? What? mg upon r1. Okay, see the scenario. mg upon r1. So what we can write? M will be equal to what, guys? M will be equal to what? R1 into cos of alpha plus phi. See the point here, everyone. Alpha plus phi divided by what, guys? G. So what is the value of R1? We calculated 110. I have written here for my reference. So 110.85 point how much, guys? 305. So tan of alpha is how much, guys? 3.18 plus 8.5308 divided by what, guys? G is how much? G means acceleration due to gravity, 9.81. So please everyone do this calculation and tell me the value of mass. Everyone, please do this calculation with me. So how much? 11085. Okay, yes, it is not a 10. Okay, good guys. So always be attentive. I may do such type of mistakes. So here, very good. So it must be cos. Good, guys. Any more mistake from my side? So please always be attentive. So I may do such type of mistake. 11085.304 into what, guys? Cos of 3.18 plus 8.5308 divided by what, guys? 9.81. So how much answer we are getting? हाँ 1106.4789 means can I take? So 1106.4789 4789 or can I take 48 kg? So we got the value of, this is what our part A answer. In part A answer they were asking us, what they are asking us? They are asking us mass M. So please everyone, please write down all these things. Okay, simple, very simple scenario, guys. Please everyone write down all these things. Now what they are asking us in the B part? What they are asking us in, guys, B part? See the B part here. The force required to remove the wedge. Here means, here what they are asking us in B part? They are asking us F out. See the point here. I am going to draw the drawing of our scenario. So here in this question, what they are asking us in B part? Force required to move the wedge out. See the point here. Force required to move the wedge out. In the A part, for the A part they have given us force required to drive the wedge in. How much force they have given? 4.5 kilonewton. But here they are asking us force required to move the wedge out. Means in B part, what is our target in B part, guys? They are asking us what? F out. Guys, just tell me the value of M, everyone. What M we calculated? 0.048 unit kilogram. We have written unit also now. Check it once again. So here what we have, this is what our engine bed plate. This is what a wedge. Okay guys, see the scenario here. This is what a wedge. This is what a stool. They have given us this is what a stool. So this is engine bed plate. So here I am going to show angles also, whatever things I require I am going to show. So this will be what guys? This will be what? Our mg. Here there will be what? F out. This is what? Our angle of friction. This is what? This angle of this plane, alpha. Here also same same tapered on both sides. What they are saying? Same tapered on both sides. So that's why this is alpha. This angle is also guys alpha. Here also coefficient of friction is same. Here also coefficient of friction is same. So phi is same. Okay guys, try to see the scenario here. So here we have a two inclined plane. See the scenario here. What we have? We have a two inclined plane. And in two inclined plane, when we want to move the object down on the inclined plane, try to see the scenario here. We have a two inclined plane, and two inclined plane means whenever we have an inclined plane, and on the inclined plane, if you want to move the object down the plane, what is the force we required? If you remember our one case, in one case we discussed one scenario here. See, we have discussed this is what our alpha, this is what our object, okay? For our reference I am writing. This is what our weight mg. And this is what our horizontal force F. And here in this scenario, phi is greater than alpha. Remember, if phi is greater than alpha, then object will not come down automatically due to its weight. If phi is greater than alpha, try to see my point. If phi is greater than alpha, okay guys, see the point. If phi is what guys? Phi is greater than alpha, then object will not come down. Object will not come down due to its own weight automatically. What we have to do for to move the object down the plane? To move the object down the plane, what we have to apply? We have to apply force F. And in this scenario, what will be the value of force F? We have seen mg tan of what guys? Mg into tan of what? Phi minus alpha. In this scenario, we have seen our case number 4 of horizontal force. This is what the case we have seen in our horizontal force. Try to see the scenario. So whenever we want to move the object down the plane, then how much force we required? F will be equal to what? Mg into tan of phi minus alpha. The same scenario will be here also. The same scenario will be for the F out here. Means we want to move down the plane for this plane and then this plane. So here F out will be equal to what expression we can write for F out? What expression for F out we can write? For this plane, what is the load? Mg into what guys? Tan of phi minus alpha plus for this plane mg tan of phi minus alpha, and for this plane same mg tan of what guys? Phi minus alpha. In last lecture, what we have seen, in last numerical what we studied, there also I have given you extra questions, C questions. In that questions also I ask you to find out F out. But in that questions, our one plane is horizontal, so that's why here there only mg into tan phi. But here both the plane is what? Inclined. So for top plane mg tan of phi minus alpha, for bottom plane mg tan phi minus alpha, and here both are same. Why same? Alpha is same, coefficient of friction is same. If coefficient of friction is same for both the plane, then angle of friction is also same. Try to see my point here everyone. So what? So F out will be equal to what guys? What F out will become? Force required to drive the wedge out. See the point here. So 2 times mg tan of what guys? Phi minus alpha. So F out will be equal to what? 2 times mass is how much guys? Check it out. 1106.48. G is how much? 9.81. Multiplied by what guys? Tan of phi is how much? 8.5308 minus Alpha is how much? 3.18. Please everyone do the calculation and tell me the value of force out. Everyone, please do the calculation, tell me the value of force out. How much we are getting, guys? Mass? Sorry, how much force we require? Yes, correct. Very good. So 2033, it will require less force na. In this scenario, phi minus alpha na. Earlier phi plus alpha na. Are you getting my point? So this is what our yup out. Okay guys, anyone have any doubt in this discussion? Anyone have any doubt in this discussion? Try to see the scenario here. Okay guys, please everyone draw this drawing properly, then write down this one, and if you want, you can, for your reference, you can draw this drawing also. This is for your reference. In exam, this much is sufficient. Okay guys, please everyone.